open the session. Hi friends, good afternoon. Myself, SP Pavani, I'm going to share you some interesting interview questions. Right. Today I'm going to discuss detailed information regarding the ensemble techniques. Right. Now let's start the session. What do you mean by ensemble learning? What is? Yeah. Good afternoon, Charan. What is ensemble learning? Ensemble learning is a machine learning method which uses multiple learning algorithms to obtain a better predictive performance. We may have so many algorithms, right? So ensemble learning is a machine learning method which uses multiple learning algorithms to obtain a better predictive performance algorithm it will choose. Okay, suppose we may have model A, model B, and model C like that. It will generalize all the models. Okay, suppose you have a data, you have some training data. The trained data will be given to model A, model B, and model C. Then those models will do some predictions, right? Those predictions will be generalized, and this ensemble learning techniques will give you a best model, a better model for you, which gives a high performance predictive value. So ensemble will give you a better result comparing to any other learning algorithms. Okay. If you have so many algorithms, so many models, then ensemble will give you a better result when diversity among the models will exist. Is it clear? This is about ensemble learning technique. So in the same, if you take the ensemble learning techniques, then the first thing comes in mind is random forest. My question is, what is random forest? I'm waiting for you. Random forest is a type of ensemble learning method for classification or regression and any other task. random forest is a type of ensemble learning method which is used for classification models as well and regression models as well and any other task. Yeah. Random forest works by constructing many ration trees at a training time. How it will work, guys? How random forest work? Actually, it works by averaging several decision trees at different parts of the same training set. If you have a training set, right? So, random forest, if you apply, then what it will do? It averages several decision trees at different parts of the same training type. Okay. Yeah. You might have heard about some base models. What do you mean by base models? My next question is, what are base models? In case of ensemble theory, these base models are also called as weak learners. You have to remember this. Okay. Base models are also have another name called weak learners, which can be used as building blocks for designing complex models. Here, what we do? Here, we have to combine several building blocks in order to build a complex model, not only a single complex model, many, okay, more complex models. So weak learners we use in order to get a best model by making it a complex model. No, as we can observe that whenever we take random forest, we are talking about decision trees also, isn't it? What is the relation between the random forest to decision trees? What do you mean? Means my next question is, how can you relate random forest to decision tree? How can you relate random forest to decision tree? Random forest, of course, we know it is ensemble learning method. How it will work? It construct by constructing decision trees, right? So random forest can be constructed for both classification and regression tasks. You can say here, how can you relate? How can you relate? My question is, those who have just joined, my question is, how can you relate random forest and decision trees? You can say random forest outperforms decision trees. What happens actually? Decision tree train a specific data set, and sometimes some overfitting will exist. Okay, and by creating random forest, decision trees, number of decision trees can be trained on different subset of the training data set, and the different decision trees can be averaged with the goal of the variance, decreasing the variance. Shall I repeat it? Your answer should be like decision tree is a trained, if it is giving some overfitting on a specific data set, then random forest, if you apply random forest on it, what will happen? Decision tree can be trained on different subsets of the training data set, and then different decision trees can be averaged. They can be built with the target, with having some target, decreasing the variance. Okay, it is important question. Yeah. Now, what are the differences between bagging and boosting? What are the differences between bagging and boosting? Anyone? Bagging means what? Let me write the answer too. In case of bagging, what do? It mostly aims at reducing the variance. Okay, bagging. Shortly, I'm writing here, aims at reducing the variance. Right. Now, what is boosting? What is boosting? It mainly focused on reducing bias. Boosting aims at reducing what? Bias. You have to remember, right? So here, bagging aimed at reducing the variance, while boosting aims at reducing bias. Okay. And yes, Satya, bagging is a method of merging same type of prediction, and boosting is method of different predictions. Yeah. So bagging can be from, it can be, bagging can be parallelized. Okay. It can be, you can say, it is parallelized, and it is from different models. Okay. Which are different models which are fitted independently from each other. And boosting, if you see, it cannot be parallelized. If you see boosting, you cannot parallelize the boosting. Why so? It goes on sequentially. Okay. It goes on, it fits the sequentially several complex models. And in case of bagging, what will happen? Different models are fitted. Those models are independent to each other. That's why parallelly we can able to do it, right? And sequentially it will go. Are you able to understand, guys? I mean here, suppose, let's see, just a second. Are you able to see what I am writing on the screen? Here, bagging means parallelly. Here, we always say that parallelized means bagging parallel, and boosting will do boosting. We do sequentially. What do you mean by it? You mean that here, suppose here you have some data set, right? And this data set be taken to some models. Suppose here I am considering 3 models. Okay, and here you got some, you will build some model. Okay, this is raw data. This is raw data, and here these are all models. It may be M1, M2, M3, like that. Okay, from this you are going to predict some. From this model you are getting some prediction. You may call it, okay, P1, P2, like that you may say. Okay, you have some values here. From this, what will happen? The bagging from these models, you are going to, or by comparing all these individual models, what is going to do? You are going to take the best one, and here it will work. You are choosing the best one. Okay, this type of work, which is called the bagging. What do you call it as? Bagging. Are you able to see what I am writing on the screen? Okay, so it is called the parallelly, these things are going on. Okay, and here you are going to the variance, whatever the values may, here you might have some value, here you might have another value. Okay, and here you might have some next value, like that. Okay, this model, by applying bagging, what will happen? It reduces the variance and you will get best accuracy. Okay, which is the best one, you will get the best one, right? Now come to Now come to boosting. What do you mean by boosting? First, whatever the data you have, this is the raw data I have. Okay, this is the raw data I have. And here I'm going to apply some, yes, I'm going to build some model. Okay, first I'll build some model here. And I see the performance of the model. Okay, and here I'm going to see the performance of the model and I'll get some value. Okay, here I'll get some value. Okay, and here the model, the same model. Okay, here I got some bias. Okay, then what I have to do again here, whatever thing I want, I haven't got here. Okay, the output accuracy, whatever I want, that I haven't got. Then what do? Again, you perform it. Again, you build a model. Okay, here I'm going to build a model here, and here I'll do some predictions. Okay, and here I'll do some predictions, some assumptions and all, and again I'll see the accuracy. Okay, are you getting my point? Okay. So again, if you see the accuracy, then what will happen? Okay, is it satisfying it or not? Here it is not satisfying. So you have come to this one. Here also it is not going to satisfy. Then what do? Again, you build a model depending on this. Okay, from this again you build a model. From here you build a model and you predict it. Again, you are going to see the variance and all. So here, if you see the accuracy, it is working. Okay, it is called sequentially sequentially applying several complex models. It is, what are you doing here? Here you are doing sequentially applying the models. This means that, okay, parallelly in case of bagging, what are you doing? In case of bagging, you are doing it parallelly. Parallelly means the raw data be given and some models are done, and parallelly you are doing each model and you are getting the best accuracy. How you can in the way how you are doing? Using the parallelized model. And in case of boosting, what are you doing? First you are taking some model. If it is not working, again going to another, again going to another. By that you are, means what you are saying, if it is not fitting, means what? It is a weak model. What do you say? It is called as a weak model. So here these weak models, depending on these weak models, assumptions and all, what you are doing, you are reducing the bias. You are reducing the bias. So this is the scenario existing exactly in case of bagging and boosting. So you can say in case of bagging, parallelized will exist, and by that you are able to reduce the variance. And in case of boosting, depending on the base models, I already explained you what is a base model and all. Okay, so depending on that, the process is not parallelized, and here what are you going to do? Here you are going to reduce the bias, right? I think it is clear for you now. So this is very important question. So bagging, and what is the difference between the bagging and boosting? Bagging and boosting, parallelized, not parallelized, and it reduces bias. Boosting reduces bias, and bagging reduces the variance. Yeah, let's move to next point. What is that? In case of ensemble methods, you might have heard another one which is called my next question is, what do you mean by stacking? What do you mean by stacking? You can say it as a stacking work. What else? What do you mean by stacking, or how it will work? Yes, Asish. Okay, Amal. Yes, Ashish, it is good. It is heterogeneous. It means we can use different models. Yes, very good. So stacking means what? Several, whatever the weak models we build, whatever the weak learners you may call, several different type of weak learners can combine them, and by training them, we are able to get the meta model to output predictions. Okay. So what are you doing? By using weak models, you are going to combine them and train them. And in order to get predictions based on the multiple predictions of the weak models, you are building a meta model and you are trying to get the best prediction. Right? Suppose, I think if you are aware of taking the stacking and all, if you are aware of it, what do you do? What are the steps you do? First, what are the steps you do in case of applying some stacking and all? My next question is um, steps in stacking. What are the steps? First, what do you do? First, you have to split the training data, right? You have to split the training data. Next, you have to choose weak learners and you have to fit the data, okay, for the first fold. Then what do you do? Then each of the weak learners, you have taken some weak learners, right? So from each of the weak learners, you have to make some predictions in order to observe the second fold. Okay, what you did? First, you have splitted the training data into two folds. In the first fold, what you have done using the first fold, some weak learners you have to choose and fit them to the data, to your data. Then in the third step, what do you do? For each of the weak learners, you have to make some more predictions, okay, in order to observe for more observations in the second fold. After that, in the fourth step, what you have to do? The meta model, whatever the final model is called the meta model in this stacking, okay, you have to fit the meta model on the second fold using the predictions made by the weak learners as inputs. I'm repeating, in case of stacking, how it will work? Data split. Yes, Ashish. So in case of step 1, what do? You have to split the training data. Split the training data into two folds. Right. And in the second step, what do? You have to choose the weak learners. Okay, you have to choose weak learners and you have to make some predictions for observations in the second fold. Okay, the predictions, weak learners, and these weak learners will give you some weak learners. These weak learners, what it will give you? It will give you some predictions, right? These predictions are going to be some predictions you will get here, right? These predictions are going to be the observations of the second fold. Are you getting the point? These predictions are going to be observations of second fold, right? Next, fit the meta model on the second fold. What do you do? What do you do after once you get the observations for the second fold? Then what do? You have to fit the model, okay, for the second fold. Okay, fit the meta model. Fit the meta model for this second on this second fold, and predictions should be done. So finally, what is going on? First, you have whatever the inputs as weak learners you have taken here, whatever the inputs you have considered here. Depending on these weak learners, only you are getting the outputs, isn't it? So what you have done? You have done the splitting the training data into two folds, and from the first fold, what are you have chosen the weak learners and some predictions you did, and you have done some model fitting and all, and the observations whatever you got here, those are whatever the predictions you are getting, okay, those are becoming the from the weak learners, those are becoming the observations of the second fold. After that, what are you doing? After getting the second fold observations, you have to fit the meta model, and using these predictions, using these observations, you have to fit the model, which is called the meta model, okay, and you will get a good predictions compared to the previously. So what you are doing in stacking? From using weak learners only, you are getting the best predictions, isn't it? So this is the scenario existing in case of stacking. I think you got the point. Yeah. Now let's see. Yes, Ashish, it is a data split. Just I'm observing about whatever the charts I'm receiving in the chat box. I'm observing all those. Only Ashish Kumar giving answers. What about the remaining? Yeah, fine. Okay, here we are talking about the meta model and all. What do you mean by meta learning? You have meta learning also. What do you mean by meta learning? It is nothing but a learning about learning. Okay. What is meta learning? Learning about learning. In machine learning algorithm, mostly you may have learn some outputs and all. Machine learning algorithms will give you some outputs and all, right? So depending on these outputs, you have to catch the best one, which fits the best accuracy. Okay, that is called the meta learning model. For example, if you see fitting a meta model, just as we have discussed, fitting a meta model on the outfold means outfold. What is the outfold here? Two folds we have taken. Outfold is second one, right? So outfold, out of fold predictions from the any cross validation you may do. Maybe it may be k-fold cross validation you can do, right? Just I'm going to generalize the meta model, meta learning and all. I think you have understood. Okay, till here we have gone through some points which are bagging, boosting and all, right? So here I'm going to ask you one question, that if you if I say decision tree, let me write the question. My next question is decision tree is in ensemble methods or not? Is decision tree is in ensemble methods? Quick answer I want. Yes or no? Ashish, are you saying yes? Why? Actually, the answer is no. Decision tree is not a part of ensemble method. Decision tree is not in ensemble method. Single tree, if you consider, that is only used for classification purpose, right? That is used for classification purpose. Random forest is random forest is in ensemble method, where we can use multiple decision trees to predict outcomes, right? Is it clear? So decision tree is not ensemble method. Decision tree is not an ensemble method. It is only, yeah, Ashish, you said no. Fine, very good then. Good. Yes was for previous question. I see. Okay, Ashish, good. Good. Okay. Yes, Sai Prashant, decision tree is a rules-based technique. I see. So here, and for random forest ensemble model, we use multiple decision trees in order to predict outcomes, right? Good. Then my simple question is, what I have explained till now, just on that I want to ask. Okay, give example for, my next question is 9. Yeah. Example for sequential ensemble method. Sequential ensemble method. Yeah. What do you mean? What is the example for sequential ensemble method? Ensemble. First, let me ask you, ensemble methods, how many we have? Yeah, very good, Ashish. ADA boosting. ADA boosting is the example of sequential ensemble model. Generally, boosting means what? From the previous predictor, the mistakes, whatever mistakes the previous predictor will make, it will give you a better predictions, okay, in the future, right? So what it does, this boosting technique, this type of boosting technique will do, it combines several weak based learners to form one strong learner. So it significantly improves the predictability of models, isn't it? So sequential ensemble technique example B, ADA boost. Yeah, ADA boosting. So what do you mean by sequential ensemble here? Okay, you say, what do you mean by sequential ensemble? XZ-boost is made up of RF ADA boosting XZ. That's why it works parallelly too. I see. Good. Okay, what do you mean by sequential ensemble? Sequential ensemble means base learners are generated sequentially, isn't it? Okay, now I'm asking you, which ensemble model help you reducing variance? Yes, I Prashant, ADA boost. Yes, it is. My next question is, which ensemble model helps in reducing variance? Let me scroll up. Yeah. Variance. Which model? Yes, Ashish. Sequential. More weightage is given to wrongly classified values. Then it is sent to next week learner. It is sequential. Very good. It is bagging. Yeah, reducing variance. Which one we use? For this question, what is the answer? Ashish? Sai Prashant is saying bagging. Ashish is saying bagging. Yes, it is. Answer is bagging. Okay, fine. Then what about the overfitting in decision trees? What do you do? What do you do to avoid overfitting in where do you face this overfitting problem? Where do you face this overfitting problem, guys? Only Shai Prashant and Ashish Kumar, these two guys are giving answers. What about the remaining friends? What do you how do you what do you do to avoid overfitting in decision trees? Pruning technique. Very good, Sai. Pruning technique, pruning we do. What type of pruning it is? Two types of prunings, two approaches are there actually. If you ask, in order to avoid overfitting, okay, we have two approaches. First one is the pre-pruning and second post-pruning, right? What do you mean by pre-pruning? What do you mean by pre-pruning? What is pre-pruning? Yeah. Yeah, Nishanti, it is pre-pruning and post-pruning. Two approaches are there. Pre-pruning means Ashish. We cut a tree, live growing completely. Acha. Post-pruning, we let the tree grow till end and then cut. Yes, it is generating. You can generate fewer branches, okay, for pre-pruning, and for post-pruning, full branches you can able to generate and then you can remove parts of it. Very good, Ashish. Right. So pre-pruning means what? You have to generate fewer branches only, and you can able to make the size or a maximum depth of cut. Okay. How can you get the results for pre-pruning? Either a size, okay, either a size you kill or maximum depth cutoff you may get. Okay. For what is post-pruning? My next question is, what is post-pruning? Here, till to the end, you have to make it. And how you get the output? Post-pruning? It will compare statistic or backed up estimated error rates also it will give you, right? Very good. Yes, we can do all this by using the parameters. Let us see. Sai, he is posting. Post-pruning is more accurate till the end and cut it. I see. Very good. Nishanti, bagging. For which question you are giving, Nishanti, bagging answer? Yeah, okay. When you have gone through this, you might have gone some sampling and all. So here, my next question I want to ask you, samples, populations, you might have known. Here, as you are saying some statistics and all, you are giving answers per parameters here. I'm asking you, what do you mean by, okay, what is sampling error? What is sampling error? In case of statistics, you might have, I'm giving you clue, you might have populations, samples, parameters. As you are saying parameters and all, that's why I'm asking this question. What do you mean by sampling error? What is that? The difference between population and sample is called sampling error. What is that? The difference between population and sample. Difference between population and sample is called sampling error, right? Ashish Kumar, sampling error is when sample does not match the population. Yeah, it will not match the population, of course. That's why error we will have. Nice. Next. Here, some information I want to ask you guys, that is here we do some cross validation and all in order to estimate some errors and all, right? So my next question is, let me ask you a question like, what is cross validation? Cross validation. Okay, in machine learning, till now we are discussing something like validation. We have cross validations and all. What is cross validation actually in machine learning? So cross validation is, Sai Prashant, in statistics, sampling errors are included. What is that? Good when the statistical characteristics of a population is estimated from a subset or samples of that populations. Okay. Okay, Ashish Kumar, using cross-validation CV, we can give data in subparts to our model. Yeah. So cross-validation is a technique which we use in ML. For what purpose we use? For evaluation purpose we use. Okay. For evaluation purpose we use. Okay. What we evaluate? The training ML models. Okay. Which the training models which are built based on the subsets, okay, of the input data. Okay, first you have to take the subsets of the input data. On that, you have to build some several machine learning models. Next, you have training. You have to train them, and then you have to apply the CV cross validations on them. Okay. So you have to evaluate them basis on complementary subset of the data, right? So, fine. Sai Prashant, Cross-validation is a statistical method of evaluating and comparing learning algorithms by dividing data into two segments. Nishanti gives the accurate measure. Yes. Okay. So here, what type of cross-validation you have? Types I want. My next question is types. Types of cross-validation. Types of cross-validation. What are types you have? Yeah. Yes. What do you mean by cross? Yeah, Ashish. What do you mean by no? What are the types of cross validation? What are the types of cross validation? You have k-fold cross validation. Yeah, leave one out. Hold out cross validation, k-fold cross validation, leave p out cross validation. Repeated random subsampling validation. So many we have. So many means majorly time series also there. Time series cross validation. Yes, Ashish, there are more. Maybe 8 or more we may have. Yes. Okay. So guys, in this session, what we have discussed, just I want to give some recap on the session. First, we have started with what is ensemble learning. I think you have understood what I have explained, what is ensemble learning and what it includes and why we use it. And next, random forest. What is that? In that random forest, we have gone through some point called base models or what is then the name for base models? Question, last question for this session. What is another name of base model? What is another name of base model? Weak learners. Okay, so how can you relate random forest and decision tree, right? How can you relate random forest and the decision tree? And what is the difference between the bagging and boosting and what is stacking? And we have already gone through decision tree previously, and again I have recapped that. And is it ensemble method or not? What is the examples? What is reducing variance? And how can you avoid overfitting in case of decision trees? Okay, what is pre-pruning and post-pruning? Right. And what is sampling error? And cross validations we have discussed. I think all of you got some information using this session. Thank you for attending the session, guys. Have a nice day. Happy learning.